Graphing polynomials in factored form. Before we get to the graphing, let's do some pre-work. For example, what if we wanted to graph y equals x minus 2 squared? Now you should have already watched the video on transformations that comes before this section. If you haven't, I recommend that you go back and watch it at this point. But we should know that the graph is a parabola that gets shifted to the right 2 spaces. What's going to become important for us is not only the shift, but the fact that this graph does not go through the x-axis. You'll hear me say it bounces off the x-axis. What about the graph of y equals x plus 4 cubed? Now in the transformations, we do not explicitly do cubic transformations, but we understand how they work. This dashed line, I'm only drawing a dash to show you that it's not the graph that I'm really concerned about. But if it was not dashed, that would be y equals x cubed. So y equals x plus 4 cubed is that graph that gets shifted to the left 4 spaces. The important thing that I want to get out of it for this particular video is the fact that my graph goes through the axis. That is, it does not bounce off the x-axis. What if I just had the graph of, say, y equals x plus 1, which is a line that goes through not only the point 0, 1, but also the point negative 1, 0. So you can think of this as the line being shifted 1 to the left. That is the parent function y equals x getting shifted 1 to the left. But the most important part is that the graph goes through the axis, at least the most important part for what we're about to do. Now, why is this? Let's go back to y equals x minus 2 squared. And I'm going to draw a sign chart. If you've never seen a sign chart before, basically, we take a number line and put our zeros on the chart. And then we test other x's on either side of my 0, or in between zeros if there are many, to see the values of my function. And I don't really need the values. What I need is whether or not y, our function here, is positive or is it negative. So if I plug in x equals 2, clearly y equals 0. Now this is the only 0, meaning this is the only place that y can change signs. So if I choose a value such as like x equals 4, and I plug it into my function here, notice that I get a positive value for y. In particular, I get 2 square root of 4. It's just coincidentally 4. But the important thing is that y is positive. And if I chose an x equals 3, I would get a positive y. If I chose an x equals 8, I'd get a positive y. For all x's over here, we get a positive y. Now I'll do the same thing on the other side of the 0, x equals 2. Choose any x value over here, because whatever sign, positive or negative, I get for y, I'll get it for all x's in this region, on this part of the domain. So if I choose x equals 0 and plug it into y, I get negative 2 all squared which is positive. So what happens here, and I'll redraw it right here on the side, this kind of part of it, is that we have x equals 2 is the 0, and then y is positive to the left and to the right. So we bounce off the axis. But what if I were to do this with y equals x plus 4 cubed? I want to make a sign chart. I'm going to put my 0, that is x equals negative 4 gives us y equals 0. It is the only 0, so I can choose any value bigger than negative 4, that is any x value. I'm just going to choose x equals 0. And notice how we get 0 plus 4, 4 cubed, and all I really care about is that y is positive. I put it above the line here. It doesn't really matter where you put it, just so you can see it and know what's going on. That means for any x value greater than negative 4, y has to be positive, because y can only change signs at the 0. Let's choose any x value less than negative 4. So I'm going to choose x equals negative 7. It doesn't matter. I could have chosen x equals negative 6. Or x equals negative 10.48. Does not matter. Because at this x and all x's in that region, I will get y is negative. Which means for any cubic at the 0, the y value will change signs. It'll cut through the x-axis. There's the y, but in general, if we have something squared or something to the 4th or to the 6th power, it doesn't really matter. All of these will make the graph bounce off the x-axis. But if I have odd powers, and it doesn't really matter what that odd power is, at all of these roots, or these zeros, the graph will cut through the axis. So let's use this idea to graph some functions. And let's do f of x equals x plus 3 times x minus 1 squared times, let's say, x minus 4. I'm going to start by plotting the zeros. So 1, 2, 3. So x equals negative 3. And then another 0 is at x equals positive 1. And my final 0 at x equals 4. Now, what degree polynomial do we have? So the degree of the polynomial is the highest power of the polynomial. So what is the highest power of my polynomial f of x? Now you might say squared, because it looks like the highest power is a 2, but that's the highest power of a factor. If I were to multiply f of x completely out, do you agree that you would have an x to the 4th plus some other things? And so the degree of this function is 4, because the highest power when multiplied out is 4. So I could say this f of x is a 4th degree. Now, how can I use the idea we just learned with some other ideas to graph this. Well, in the previous video, we used parent functions to get end behavior. Let's do parent functions to help us graph this. So I have a positive x to the fourth, which means I know the graph must look like this. Somehow, or something close to that. I also know that at x equals -3, the graph will cut through the axis. At x equals 1, the graph will bounce off the axis. And then at x equals 4, the graph will again go through the axis. Now, does the graph look exactly like this? No, it's definitely not drawn to scale. But it looks something like this. I certainly have the shape correct. I have the bouncing nature correct, if you would. I have my zeros correct. The one thing I probably don't have correct is the y-intercept. So what is the y-intercept of this graph? Recall that the y-intercept is when x equals 0. So I could simply plug in 0 back into my function, and I would get 0 plus 3 times 0 minus 1 squared times 0 minus 4. And if I were to multiply that out, we would get 3 times positive 1 times negative 4 equals negative 12. So really, I should have put my y-intercept at negative 12. Now, if you will accept that my graph is not drawn to scale, maybe after the fact I could say, oh, you know what? I meant for this really to be negative 12 there. And then my graph is pretty accurate. Let's do another graph. Let's look at f of x equals negative x plus 5 cubed times x minus 2 squared. What is the degree of this polynomial? Well, if we were to multiply this all out, would you agree that we would get a fifth degree? That is, f of x would be negative x to the fifth and some other things with lower powers. So how could we draw this one? Well, let's start with our parent function. A negative x to the fifth looks like this, in general. It might not have as many twists and turns. It might look more like a negative x cubed, but it definitely has that type of shape. Let's plot our zeros. That'll be negative 5. So I'll say that my x-axis is to scale. My y-axis is not necessarily to scale. I'll plot my other 0. So what we have, the zeros are negative 5 and 2. Let's also look at the y-intercept, because that might help us draw some things, although I don't think I need it, but maybe it helps. So the y-intercept, when x equals 0, is negative 0 plus 5 cubed times 0 minus 2 squared. So 5 cubed is 125. And then we have negative 2 squared is positive 4. So we have 125 times 4 which is 500, but the negative sign out front here means that the y-intercept is negative 500. So way, way down below, but I'm going to pretend that this place right there is y equals negative 500. And now let's use the idea of cutting through the axis or bouncing off the axis to finish off the graph, along with my parent function, which I think will look more like this. Doesn't look like I'll have so many twists and turns. Our first zero of negative 5, what's cubed, so I know we'll cut through the axis. And we'll go down here. It might not be the minimum point. Maybe the graph really goes something like this and then back up through it. I'm not worried about that. I could determine that if I needed to, but that's not the point of this. We're just trying to get a rough shape. And now I go back up to my next zero, which is 2, but since it's squared, I know it's going to bounce off the axis. And I can get a pretty good shape, a decent enough shape for me, for the graph f of x.